Okay, for review problem 3.5, we need to find the marginal density functions, the marginal PDFs of x and y, if we have a joint PDF that looks like this, y times e to the minus xy minus y. Okay, so to get started, first we find the marginal density for x, and we get this by integrating out the y. So integral of y times e to the minus x plus 1 times y dy. And for this example, the values of y go from 0 to infinity. The function is defined in the entire upper right quadrant. And so the values of y go from 0 to infinity. Okay, so how do we do this? Well, the answer is I can write this immediately. If we recall, the density for a gamma distribution with parameters 2 and lambda looks like this. Lambda times x to the e to the minus lambda x. That should be lambda squared, pardon me. Lambda squared x e to the minus lambda x with 1 over 1 factorial out here. That's the density for a gamma 2 lambda distribution. If I take the integral from 0 to infinity dx, that's equal to 1. So if I kind of compare that to what I have here, let me just change letters. That means if I have the lambda squared y, e to the minus lambda y dy, that's equal to 1. And that pretty much matches what I have here, except my lambda is x plus 1. So if I replace lambda by x plus 1 squared times y e to the minus x plus 1 times y dy, that's equal to 1. And so by using this PDF, I know automatically that this will be equal to 1 over x plus 1 quantity squared. And this will be defined for any x greater than or equal to 0. So that's the marginal density for y, which I get by integrating, but the integral I did was by just simply recognizing that this integral matches one of our common PDFs, in this case the gamma distribution. Okay, next we need the density for y, so that's going to be f sub y. So I integrate this time over all the possible values of x going from 0 to infinity. So y e to the minus x times y times e to the minus y dy. All right, now how am I going to do this one? Well, I recognize again that using the exponential distribution, so that's the notes for this one. For the exponential distribution, I remember that the integral from 0 to infinity of lambda e to the minus lambda x, and I'm sorry, there should have been an x here, not a y. Lambda e to the minus lambda x dx, that's equal to 1. That's the PDF for an exponential distribution. And that's exactly what I have here, except instead of a lambda, I have a y. So this part right here exactly matches the what I have here, where I replace lambda by y. So this is e to the minus y times the integral of a PDF. The PDF of an exponential distribution with parameter y as opposed to parameter x. And so this will be equal to simply e to the minus y, where y is greater than or equal to 0. So that is the marginal density for y for this joint PDF.